Hello. This time I'm going to explain the lens maker's formula, and it is the relation that it is the formula that relates the focal length of a lens and refractive index and also the radii of curvatures. A lens has two curvatures, so it has two radii of curvature. One by f equals to mu 1 minus 1 into 1 by r1 minus 1 by r2. This is the formula we are going to use. We are going to prove. Here, f is the focal length, mu21 is the refractive index of the denser medium with respect to the rarer medium, and r1 is the uh, radius of curvature of the first surface and radius of curvature of the second surface. And we are going to use this formula minus mu1 by u plus mu2 by v equals to mu2 minus mu1 by r. This is the formula for refraction on a spherical surface. Here we consider that light comes from mu1 to mu2. If ray comes from mu2 to mu1 and mu2 will interchange. Okay. Let's go to the assumption. We consider a thin lens. Since it is thin, in the drawing we draw a thick lens, but we have to consider a thin lens. If we consider thin lens, the distance measured from the poles of the two surfaces of the lens can be taken as to be the same as the distance measured from the optical center of the lens. It means CO is equal to P1O and Ci is equal to P2I. Since P1, C and P2 are very close to each other, so we can consider as 1 point. These 3 points as 1 point. They consider them as coincide. And the next one is the aperture of the lens is small. The diameter of the lens, this is small. And what else? Number three, the object is a point object. We consider only a point object. And for the number 4, the incident ray and the refracted ray make small angles. Okay, incident ray and refracted rays. Incident ray, refracted ray. These angles are small. And the Cartesian sign conventions, all the distances are to be measured from the optical center. From the optical center. And the second one is the distance measured in the direction of incident ray are taken as positive, and those measured in the opposite direction, in the direction opposite to the incident ray, are taken as negative. Here, if we all the distance are measured from C. If we measure CO, the distance of O, it will be CO from right to left in this direction, so it will be taken as negative. If I measure the distance of I, it will be CI. It is measured from CI, so it is along the incident ray, so it will be taken as positive. It means left side are taken as positive, negative, right side are taken as positive. So this is the diagram. We consider the object. We start with the lens. The principal axis. Start with the lens and then principal axis. After that, draw the incident ray, this ray. And don't forget to put arrow marks. It gets refracted, and this is the normal. It comes from the rarer medium to denser medium, so it bends towards the normal. And here there is another surface. The refraction is from denser medium to rarer medium, and this is the normal. This is the normal. It bends towards the no, it bends away from the normal, and finally uh, it comes to I. And this I1 is the point where the image would be formed if the lens, the material of the lens fills all the right side. So there will be no more refraction. We consider there were no surface on this side. Okay. Mm, First, we take this surface. We consider x p1 y, refraction on x p1 y. This is x p1 y, and this is the object, and this is the normal, and it is the incident ray, and then it gets refracted and bends towards the normal, and the final image is formed at I1. So P1C1 is R1. Here, let us apply the formula. This is for the refraction. The first case, refraction at xp1y. The formula was mu1 by minus mu1 by u plus mu2 by v equals to mu2 minus mu1 by r. Here u is u, and v is v1, and r is r1. No need to apply the sign convention again, because the sign convention has already been applied in this formula. If we write in terms of u, v1, r1, so mu1, ray comes from refractive index mu1 to material of refractive index mu2. So it obeys this order. So I can write minus mu1 by u plus mu2 by u is u, v is v1. So it will be v1 equals to mu2 minus mu1 by r. The radius of curvature of this curve is r1. This is equation 1. Okay. Then we apply the same formula in this surface. Here we consider refraction at x p2 y. It is x p2 y. Ray comes from this, and it gets refracted here. In this step, we consider the material of the lens is extended on this side. That means the material of the lens fills all the left side. So ray comes from this line. It means the virtual object is located at I1. I1 will be taken as the object, and I is the final image, and this will be V. Make a correction on your note. It will be V. I1 is at V1. So the formula was mu1 by u minus mu1 by u plus mu2 by v equals to mu2 minus mu1 by r. Here ray comes from mu2 to mu1. That means mu2 and mu1 will be interchanged. Mu1 is mu2. This is mu1, and this will be mu2. So mu1 is mu2. I can write mu2. Let me write refraction. refraction at xp2y here. Mu1 is mu2 minus mu2 by, what is u? The position of the object is v1, so u is v1. I is considered as the virtual object, plus mu1. Mu2 is mu1, and the final image v is v equals to mu2 minus mu1. It will be mu1 minus mu2 for this. Mu1 minus mu2 divided by R2. Okay, let us rearrange. In the first equation, we use mu2 minus mu1. So let us write this in terms of mu2 minus mu1. Mu2 by v1 plus mu1 by v equals to, let us take minus common, mu2 minus mu1 by r. Okay, let it be equation 2. Then adding equation 1 and 2, what do you get? Let me write equation 1 here. In equation 1, we have mu1 by u plus mu2 by v1 equals to mu2 minus mu1 by r1. That was the equation 1. If we add these two, minus mu2 by v1 and plus mu2 by v1 cancels. So we can write minus mu1 by u plus mu1 by v is equal to, let's take this as common, mu2 minus mu1. When I take the common, bracket is necessary, 1 by r1, and this will be minus 1 by r2. Okay, and here let us divide both sides with mu1. Dividing both sides by mu1, what do we get? It will be 1 by u plus mu1 divided by mu1 is 1. 1 by v. Mu2 by mu1 is mu21. Okay. Mu2 by mu1 is mu21. Okay. Minus mu1 by mu1, 1. Then 1 by r1 minus 1 by r2. Okay. We have this formula. It is not the final formula. Okay, let us consider the first principle, focus. If we put the object at f1, that means u is at minus f1. Then the image is formed at infinity. Let us apply this in this formula. This will be minus f, and this will be infinity. Then we get minus 1 by minus f1 plus 1 by infinity equals to mu21 minus 1 by r1 minus 1 by r2. What do we get? 1 by f1. 1 by infinity is 0. Mu21 minus 1 by r1 minus 1 by r2. Okay. And again, for the second principle, focus. This is the second principle, focus. For the second principle, focus, when the ray comes from infinity, when the object is placed at infinity, minus infinity, and the final image is formed at the focus, parallel rays converges to the focus. In this case, when u is minus infinity, v, the position of the image is at the focus, so it will be f2. V is plus f2. Then I can write 1 by u is infinity minus infinity. Infinity. 1 by infinity is 0. Minus infinity is also 0. Plus 1 by f1. V is f1. And then f2 now. It is f2. And the same mu2 1 minus 1. 1 by r1 minus 1 by r2. Then what else? 1 by infinity is 0. 1 by f2 is equal to mu2 1 minus 1. 1 by r1 minus 1 by r2. Then comparing these two equations, 1 by f1, this and this equation, we find that they are same. So f1 is equal to f2. It is equal to f. Say, oh, let f be equal to both f1 and f2. So we can write 1 by f equals to mu2 minus mu2 1 minus 1 1 by r1 minus 1 by r2. This is the lens maker's formula. And also 1 by f is equal to power. Power is equals to 1 by f. We can replace 1 by f with p. P equals to mu2 1 minus 1 1 by r1 minus 1 by r2. Okay, that is all about the derivation. And let us do some numerical problems. For the first one, the radius of curvature of either face of a convex lens is equal to its focal length. What is the refractive index of its material? Okay, we have R1 and R2. And both are equal to both the radius of curvature is equal to the focal length. Okay, here let us see R1 is positive side on the right side. R1 is positive, R2 is negative. So we have to take R1 as positive f. It is equal to the focal length. And R2 is also equal to the focal length, but it is negative. Then we are supposed to find the refractive index. So using the lens maker's formula, 1 by f equals to mu21 minus 1 1 by r1 minus 1 by r2. Refractive index of the material. We want absolute refractive index. So mu21 is mu2 by mu1. We want to find mu2. Let it be mu. Mu2 is mu for the material. Mu2 is mu and mu1 is 1. Okay. Mu2 is the absolute refractive index of the material, and mu1 is air. We consider it as air. Mu1 mu1 is the refractive index of air. It is equal to 1. Mu2 by mu1 is mu. So mu21 will be replaced with mu. Then 1 by f equals to mu minus 1 by r1, that is f, minus 1 by minus f. 1 by f equals to mu minus 1 by f, minus into minus becomes plus 1 by f. And 1 by f plus 1 by f is 2 by f. This will be 2 by f. So 1 by f equals to mu minus 1 2 by f. Then f and f can cancel. Then transposing 2, mu minus 1 is equal to, on this side it will be 1 by 2. Then what else? Mu equals to minus 1 becomes plus 1 by 2 plus 1. Mu is 3 by 2. That is 1.5. Okay, that is the refractive index of the material. Then one more question. A convex lens of focal length and made of glass. The focal length, it means in air. This is in air. And made of glass, the refractive index of glass, that is mu of glass, is immersed in water. Absolute refractive index of water. 1 by 5 is 3 by 2. It is equal to 3 by 2, and 1.33 is equal to 4 by 3. Find the change. We want to find the change in the focal length. It means uh, the greater minus the smaller. Here, there are two cases. The glass is placed in air for the first case. For the second case, the glass material is placed inside water. The first one is glass in air, and the second one is glass in water. Okay, case 1. Let us consider glass in water, glass in air. In air, the focal length is 0.2 plus 0.2. Since it is convex, it must be positive. 1 by F equals to mu 1 minus glass in air, so it will be glass with respect to air. With respect to air is same as absolute refractive index. Mu of glass minus 1 by R1 minus 1 by R2. Then F is given, that is 0.2. 1 by 0.2 equals to mu of glass in air is 3 by 2. 1.5 is 3 by 2 minus 1 by R1 minus 1 by R2. Then 3 by 2 minus 1 is 1 by 2. Then 1 by 0.2 is 10 by 2. Then 3 by 2 minus 1 is 1 by 2. 1 by R1 minus 1 by R2. Then we have 1 by R1 minus 1 by R2 is 10. 10 equals to 1 by R1 minus 1 by R2. This focal length is in air. In air. Let us write F in air. Case 2. For the second case, we consider glass in water. Glass in water. So 1 by F in water. Let us write FW only. FW equals to, the refractive index will be mu of glass with respect to water, or with respect to water. Okay, minus 1 by R1 minus 1 by R2. Okay, mu glass water, what is it? Mu of glass with respect to water is mu of glass divided by mu of water. So mu of glass is 3 by 2 divided by mu of water is 4 by 3. It is equal to 3 by 2 into 3 by 4. Then we have 9 by 8. So 1 by FW, it is unknown value. Mu GW is 9 by 8. 9 by 8 minus 1. 1 by R1 minus 1 by R2 is 10. And 1 by FW is what? What is it? 9, 8 minus 1. 9 by 8 minus 1 is 1 by 8. 1 by 8 into 10. It is 5 by 4. Okay, we want to calculate FW. FW is 4 by 5. Taking upside down, it is how much? 0. 545 divides 40 is 8, so meter. Okay, in water it is 0.8 meter. So change in the focal length will be the larger one. Which one is the larger? Point 2 point, this one is the larger. 0.8 minus 0.2, then we have 0.6 meter. This is the change in the focal length. Okay, thank you for watching.